Somebody's actually there.
Very lazy. What are you singing?
It's over.
What are you singing?
Why are you laughing at me?
Can you hand me my phone?
Yes. Everybody can hear your burp.
Excuse you, Michael. That's you.
That's you. That's you. You make funny noises. You know, people can hear you.
Michael.
They can hear every word you're saying right now. What else do we need? Live chat's open if you want to chat. Live chat is open. Okay, so let that. What I need is
I don't know. You're using it. It's in the closet.
trying to put this phone on a tripod so you guys can see better. Okay, there we go. There we go, that's better. Better? Is that a better view, everyone? Live chat is open. Live chat's open if you want to talk, ask questions. Just kind of getting set up. I put the phone up on a tripod, camera tripod, so now I get a better view so you guys can see what I'm doing. Just hooking up the batteries. closer. Working with 3 batteries. Hopefully that's a better view. Live chat's open. Ask me questions if you want. Just doing some testing on my generator. Do some low testing with batteries. Today I'm just using the 3. Last night I did some tests. I basically got this thing to recharge itself while it was running a load. So basically the thing's going to run forever on its own power. Got my watt-hour meters. Live chat's open. So I'm hooking up the main power to the batteries to a watt-hour meter. So I've got that hooked up now. Got the cables directly to the motor. Using lights as the ballast. Got a little sparky there. Right now I'm pumping at about 38 volts. Live chat's open if you want to chat. Hey, Buster, how's it going? Any questions, comments? Just ask. Using right now it's 37.8 volts. I'm drawing 0.006 amp hours. It's drawing like basically nothing. So basically what I'm going to do now is hook up the return charging circuit. So because the battery already has a ground into the system, all I need is a tap out from the power out with the diode, and then that'll go back to the positive end of the battery bank. So last night I did some tests with this, just with the one wire, with the diode on it. And basically as it was running, I had to slow down the timing so it was almost like a pulse, a heavier pulse. But basically returned all the power that I used going output was coming back and charging the battery bank. So I started with actually lower voltage than the voltage that I ended with. My voltage was up when I finished the test. So I was basically putting out more power and returning more back into the battery bank to sustain the bank. So the battery bank does not wear out. So works on the Newman principle. Got to have a massive coil. So this one's like just under 2 pounds. The new motor, I don't know if you can see it where you are. There's the box back there. I'm going to be building a commercial version. So the drive coil is going to be 2 pounds of 24 gauge wire with iron core. I'm using the welding rods. I cut them off and I stuff them in the hole, and then I put epoxy in there and seal them all together. And that's the metal core I'm using. Yeah, so what I'm going to do is I'm going to hook up the return. I just got to check this wire to see if I've got continuity, because I don't know if this wire is screwed up or not. Do a little continuity test. I think this wire's messed up. This one I think is dead. Try this wire here. Just check to see if this wire is good. This one's dead. Try this one. Alright, this wire's good. Alright, I knew one of my ground wires was bad. Just have to find out which one it was. So basically the return circuit, you've got the output there, so you find your positive, because I put this through a full white bridge rectifier, and then from there it goes to a light, so it's a pulse DC. And now I'm gonna use I think this is the 44070. I'll have to look up the number on it. It's a pretty beefy diode. So the diodes can be attached in line going back to the battery. And as a result of this, because it's a pulsing, I'll still get some output here, but it does get reduced to about half the power output. But the fact is, when I hook this up to return to the battery, it's actually recharging itself in the process. So that's what the test I was doing last night, and it worked actually very good. So I was getting a lot of battery return power. So we'll start it up again. So now I've hooked it up. So now I put it in a pulsing mode. You can see the lights flickering. And well, these ones, like these meters that I'm using right now are directly going from the battery. So I'm not pulsing anything through that watt-hour meter. This is straight from the battery to the meter. I don't have any watt-hour meters on the output. There's nothing there. It's more, right now, what I'm worried about is how much I'm putting out in the return. So now it's in the recharge mode. So when I built the new motor, I'm going to have that wire, that return wire, that'll be hooked up on the switch. So when I run the load full tilt, I can charge it for quite some time. And then after the batteries start going down, I want to recharge those batteries by using their own power. That return wire is going to be hooked up to a switch, and then I'll be able to flip it on and off and recharge the batteries. And right now it's recharging the batteries using its own power. Plus still pulsing the load. So I can also charge something as well as recharge itself. viewed. So I'm at 37.94 volts and the power's going up. So I'm pulsing a load out and recharging itself at the same time using one wire, one diode. So what I've done is reduce the load of the lights. I disconnected half the lights to get more charging flyback to go back into the battery. So right now it's about 37.9 volts. Now the thing is, right now it's actually at full power, so if I were to shut the system off, the batteries would actually recover themselves. Because the motor doesn't run with hardly any current, it's really not doing any damage to the battery at all. So, here, let me shut this off for a second. It's really not doing anything to the battery. Yeah. Yeah. I've heard a few things about them so far. They seem okay. I'm not pulsing any power into it, so I'm getting I think a pretty accurate reading. So already the battery, since I've shut the motor off, has gone back up to 38 volts. So the second I shut the motor off, these batteries actually start going up in voltage. They recover on their own. Because this motor takes virtually like almost no current. I got it down to 0.4 watts. So like I'm under a half a watt to run this. So, any other questions? Sorry, somebody else sent me a message and I didn't quite get it because it comes up on the screen. Yeah, I want to get a battery swapping circuit. Yeah, I've been looking at a few of them right now. Yeah, definitely I'll be looking into battery swapping circuits. Yeah, for sure. Yep, definitely one thing I'm gonna try to get hooked up. I'm thinking maybe either Arduino system or even Raspberry Pi system, maybe. We'll see. We'll see what happens. I have to do some more research on those circuits and see if they're actually worth it or if there's an easier method. Any other questions? So, well, I got you guys on. I don't know if I've shown you guys this yet. So, that's the motor. I got the circuit. That's the watt-hour meter. So I got the one wire coming off the output with the diode going directly back into the battery. So when I hook this up in the new box, this will actually be on a switch. So when I need to recharge these batteries, I flip the switch, it'll engage the power coming from the output back into the batteries and recharge the batteries. So here's the new box. I finally got my magnet wire in, the 24 gauge 5-pound wire. I'll be making some coils with that. I got another watt-hour meter. I got terminals. I got the new piezo transducer. I got that in. Some other voltmeters for the batteries. I got the box. So yeah, I got quite a bit of stuff. Yeah, so that's where I'm at. Put you back up on the tripod here so you can see what I'm doing. So I'm just basically just doing recharge tests right now. basically what's happening is I can't kill the battery. I've been running this thing like for hours on end. These batteries don't go dead. They don't go dead. I can't kill them. So, yeah, that's a good thing. I can't kill them. They're not going down in voltage. And even if they do go down, say, 1 volt, I shut the system down within 10 to 15 minutes. The batteries have recharged themselves because of their lead acid. They recover. So because I'm using such a low current going into the system, the batteries don't even notice that it's being drawn any power off of. It's so minute. Now, if I was drawing 3-4 amps off it, okay, that's a different story. These batteries are going to start feeling it. They'll start discharging, right? But that's not happening. So. Any other questions? I just got this tape on here to make the thing a little bit quieter. I got holes there, so I just taped them up. It's getting a little noisy, so. Rotor, yes. I would say just over a pound. It's pretty good. I'm using ceramic bearings. It's very smooth, almost no vibration at all. It's very balanced. Thanks, man. Yeah, no vibration at all. It sounds loud because I'm using ceramic bearings. Probably if I used like grease filled or I don't know. I could. But I find the ceramic bearings work good. Vibration? Nothing. Zero. Nothing at all. Very balanced wheel. So I'm trying to wear the battery out a bit right now, so I could do a recharge test. Excuse me. Like it's... Hey Philip, how's it going? So I was talking earlier, current input. The current input right now is 0.006 amps. .015, sorry. So basically the battery is going down extremely slowly. So all I need to do now is put one wire with a diode on it and loop that power back into the battery. So I'm going to do that now. And back off of it. And the second I do that, the voltage bumps right back up. So because I'm maintaining a high voltage, if I were to shut the motor off, the battery's totally recharged. So the motor is recharging itself right now, as well as running a load at the same time. And it takes 18 watts to light those bulbs up. Current going into those lights right now is 250 milliamps. Milliamps, and right now it's spiking about 60 volts. High voltage is about 60 volts. 60 to 80 volts, depends how I have it configured. Don't forget, guys, give me a thumbs up if you like. Any other questions? Or? So on this device, I don't know if you know, I'm using a piezo transducer. I'll show you how that looks. That's the piezo transducer, and that's what's giving me the voltage to get those lights going. The piezo transducer puts this coil into harmonic resonance.
Without that piezo, I couldn't light anything, nothing. Light maybe one light, but barely. The second I put the piezo into the circuit, it harmonically resonates with this coil. I get the output.
Sorry about that. I'll tell you the RPM. Just over 1,000 RPM. Just over 1,000 RPM. This thing could go way faster. I'm gonna bump it up. Runs, yeah, it's about 1,030 RPM. So basically the battery's staying at 37.86 volts and it's not going down very little. Plus, so I'm basically looping it back into itself again with one wire. And I'm running a load as well. Yeah, just under half a watt, 0.433 or yeah, 4.3. Yeah, just under half a watt. And to run that load completely full, it's 18 watts. It's at full power, it's not dying. It's basically making continuous power on its own power, recharging itself, running a load. And this thing's got torque too. It takes a lot of power. Like the wheel, I think, is about a pound. in weight. It's not light. And it's got 5 magnets all the way around. No more than 5. If you go more than 5, then the spark gap switch cannot give enough time interval between being open and closed for the field resistance to go to 0. And that is why it takes so little current to run this. When you're pulsing it, it's basically releasing the current draw. Yeah, I'm working on the scaled up version yet. I got the box, I got the magnet wire in this week, I got a bunch of terminals, I got these batteries here, I got a 4th one in the supply room. So I got the batteries, I got the watt-hour meters, I got 2 of those. I got a couple other meters, terminal blocks. Yeah, all this stuff is from the Patreon money. So that's where anybody who's a Patreon, that's where the money goes to get the stuff I need to make it. So I got the box down there. I don't know if you guys seen it. Yeah, see, the problem is I live in an apartment, so having like an actual ground, I don't have access to. Anyways, that's the box. So it's a server box. And yeah, so that's what I'm using to gonna be for the new generator. So basically what you see here is gonna go in that box. I'm gonna make a whole, I'm not touching this. This is my tester. So I'm gonna make a completely new motor, new coil, new everything. So anyways, I'm gonna stop the live stream. I'm gonna go back on again a little bit later on. It just doesn't seem like many people are logging in tonight, so we'll try another maybe around 10 or 11 or something like that. We'll try again. Give me time to do a couple of things here, and then yeah, we'll start another stream up. All right, so we'll see everybody. Thanks a lot. Thumbs up, and hopefully I'll be back later on tonight. All right, man. Thanks everybody for joining us. Thanks, Price.